T-shirt. Go ahead. Thank you for introducing me. Good morning. Thank you for coming on a Sunday morning. It's 11 a.m. And you survived the concert last night. Thank you so much for coming to my talk. Please submit your questions. They will be read out at the very end. Without further ado, let me kick off my talk. It will be devoted to, well, the title is What is LLVM and Why You Should Care? I'll use simple language for simple people to describe what an LLVM is. As for the simple language, I'll try to stick to it. I'll use some technical terms, some compiler-related terms, but that's going to be a real minimum. If you're not an expert on compilers, don't worry. Everything is going to be clear for you. I'll do my best. And for ordinary people, well, you are not ordinary people if you're here. But if you're an expert on compilers, if this is what you do on a daily basis, maybe you will find my presentation boring, because you probably know all of the things I want to cover. I might share some new jokes with you, though. So, what are you going to learn during my talk? First and foremost, I will tell you what an LLVM is all about, what is the underlying philosophy and the main stages of development of this project. I will also talk to you about how LLVM impacts all of us, because, you know, it does impact, at least it does impact your work. But why should we care? What does it mean for you personally? And what can we do with this new knowledge after the talk is over? Right, so this is the agenda. That's my favorite slide. I'll briefly go over this slide. This is a photo coming from the LLVM Developer Conference. These are the people who speak Russian, and there are very many Russian-speaking developers in the LLVM community. That's me, if you didn't recognize me. The rest of them are not in Russia. They are not based in Russia. When the picture was taken, they were not based in Russia, and they are not now. And there is a Brit, so your homework would be to detect who the Brit in the photo is. Just a few words about myself. I worked for different companies, primarily foreign companies. I worked for just one Russian company, but I'm going to skip that. My LLVM experience is what's more interesting and whether you should trust me. For the first time, I visited the LLVM Developer Conference 12 years ago, back in 2012. The very first LLVM-based project I implemented in 2013 when I worked for Intel. In May 2015, by the way, the last one was an internal project, an in-house project, so it was never published in the open source. In May 2015, we still worked with the open source, and the very first patch was accepted in upstream. In July 2015, I received commit access. In 2017, I was included into the LLVM dev meeting program committee, and this year I became chair of the Euro LLVM 24. Despite the ongoing political situation, the community remains open-minded towards us, which is great. So I guess I could be considered an authority, as Andrey mentioned in his introduction. So what is LLVM? What does it mean? Any ideas from the floor? Right. I do understand it's difficult to interact with the audience in such a large hall, but you know, it stands for low-level virtual machine. But this is a wrong definition. LLVM does not mean anything. This is just a proper name, and this is what the LLVM's website states. And this is done on purpose because virtual machines are not really related to LLVM. So not to confuse people, just trust me, LLVM is just LLVM. This is it. You don't need to decipher it. LLVM.org is the main website for our project, and you might have noticed that, by the way, the previous slide devoted to conference, I demonstrated a dragon everywhere, and I hope you can see it in the slide. I don't have a laser pointer. There is a dragon. The website is supporting a dragon. So the next question I get asked is why the dragon? There is a series of books about compilers, and it's a well-known series of classical hardcore books. And the title is the unofficial title is Dragon Book because a green dragon was depicted on the first edition. It became scary and scarier, and the last one features the scariest dragon ever. It's violet. It is by Ahe and Ullman, the famous compiler developers. They were accompanied by co-authors. So a dragon is now associated with compilers. And LLVM means that you score a victory against a dragon. And this is our emblem that we've had for years. Then some people said that this dragon has his head upside down, so they changed an emblem to this dragon. This dragon is named Viver or Vivera, and it's a classical European dragon from the British and the European mythology. For instance, in the Game of Thrones, they used this particular kind of dragon. And the roots go back to this series of books. The website states that these are smart and modular dragons, but I believe that the roots go back to the book rather than the series. So I have completed the minimal part of my presentation. Now you know what LLVM is. But let me give you some background, some LLVM background. And I will put an emphasis on the philosophy so that you better understand the origins. LLVM started as a fundamental research. Chris Latner is the one wearing the glasses. Shown on the right-hand side is Vikram Adhert. He was his scientific supervisor in the University of Illinois, and well, his PhD, Chris's PhD, is shown. At least the screenshot is shown in the slide. In 2005, he defended his PhD thesis. He holds a PhD degree, and the master's degree had a greater impact on the computer science development as compared to his PhD thesis. Back then, LLVM indeed stood for a low-level virtual machine. What does that mean, and what's the main idea? Let's spend some time on that. This is some historical data, I would say, because it has nothing to do with the current LLVM domain. So anyway, what Chris came up with is as follows. Let's come up with an intermediate representation of a program. It's similar to a Java bytecode, a program representation in some form which is convenient for something. And Chris, as supervised by Vikram, suggested a form which is useful for storing a program with the executable code. So that when you compile a program and get an executable code, you can run it, you can profile it, get some feedback, get dynamic statistics, and then optimize it based on the feedback received. I hope you're clear, or am I giving you too much information? I see some nods in the room. Right. Anyway, let's stop at that. This is a system which Chris named software optimization.
Всего времени жизни, извините за тавтологию, приложение.
Throughout its life span. Compilation is not just a one-off exercise. We keep on compiling and optimizing a software or an app throughout its lifespan. In 2005, Chris defended his PhD thesis. He moved from Illinois to California to the Silicon Valley, and he totally forgot about the system. And why is that? Because he was hired by Apple, and Apple started developing the LLVM. platform. Apple did not care about lifelong program optimization, dynamic systems, or anything else. They wanted a simple compiler for their own platform. And they ran into a challenge with the PowerPC when Symantec, their then partner, failed to develop a compiler on time. And that put them on the brink of a failure as far as the PowerPC project was concerned. There are multiple books devoted to that. Read them if you want to. So Apple wanted to control this important element themselves. And Apple is known for micromanaging everything. And this is especially true for the role of Steve Jobs in the company. And LLVM became a static compiler rather than a dynamic compiler. And Apple substituted for GCC. Why is that? Well, Apple decided to scrap GCC for the following reason. Starting from version 4.3, GCC started using GPL version 3 license, which was bad for Apple. And I actually heard an Apple manager giving the following version of the justification, which I believe is true. The GCC compiler, starting from GPL v3, required giving specifics of the hardware functioning. In other words, the compiler wanted more data on the commands, and Apple did not want to provide such information. Whether it's true or not, it's a mute question. I wrote an article for Harbor on LLVM story, and some people stated that the reason was totally different, but nevertheless, Apple did not like GPL v3, and Apple was not alone in that. And the latest version of GCC that Apple used in OS X was GPL v3 version. There is no such thing as an official GCC GPL v3. Chris Lattner joined Apple, like I said, and in 2005. And the first thing he did was he developed LVN GCC or GCC LVN, whatever. GCC was the front end, and LVM was the back end. Let me explain to you what I mean by the front end. I didn't want to give you any technical terms, but I have already started doing that. So this is the part of the compiler that gets the C++ language-based software. Converts it into an intermediary representation. That's why we call it the front end in the first place. It is followed by the middle end, which is the optimizer, and the back end, which is the code generator. And you can substitute middle end and front end for different programming languages if the front end is compatible with different middle ends and back ends. And this is what Chris Lattner did. He used the LLVM GCC initially, and it was a monstrosity that combined elements from two different projects. It had to be replaced. Therefore, in 2006, Chris started developing a front end for C and Objective-C languages. He named it Clang. Some people call it C-Lang. Trust me, this is a mistake. I asked Chris Lattner personally. So the right pronunciation is Clang. C stands for the family of C languages such as C, C++, Objective-C. Lang stands for language. And for Apple, it was an important programming language for their operating system. And only later, when Apple hired Doug Greger, who they launched the C++ support. Initially, they only used C and Objective-C languages. And Clang developed so well, so many people contributed to developing it, that a decade after its appearance, it absorbed the front-end business. So I wouldn't recommend that you go there. The next important milestone happened the following year. Google started using LLVM and Clang, and it contributed to developing it. Developer teams in Google can use any compiler that they like, even commercial compilers. However, it so happened that the entire Google embraced Clang for the C++ language. How come?
То, что говорят сами представители компании Google.
Well, guys from Google said that they needed one compiler for all operating systems developed by Google. That means Windows, Linux, and OS X. Well, GCC for Windows does exist, but it does not work properly. And an important thing for Google is always security, and this is the main topic of this particular conference. From the viewpoint of Google, LLVM and Clang were the best products out there. First and foremost, the statistics analysis capabilities were better. There is a static analyzer in LLVM Clang, and you can add the analysis rules there. Sanitizers is another advantage. Konstantin Serebryny, a Russian developer, developed a set of tools for, well, I guess you all aware what a sanitizer is, but it's a set of tools for dynamically checking program security, and they appear earlier in an LLVM, and their functionality is greater. Automatic defactoring is also part of Clang, and Google uses it a lot when you have to refactor a huge code database and replace a non-secure code line with a secure code line. And, well, political reasons, influence in the community. GCC is an old-timer community with well-rooted ideas of what good and bad are, and Google had a greater say on LLVM. Google started supporting LLVM in Windows, and a very interesting thing that I want to mention that shows you how open source communities work. Google started supporting two programs in the Windows, Google Chrome and Google Earth. I hope you know what Google Earth is. You can get a 3D image of the Earth. And as soon as these programs were successfully compiled and were supported by LLVM in Windows, Google stopped actively supporting Windows, and Microsoft Foundation class did not use Clang to compile files. They are not used in Google Chrome and Google Earth. That's why Google no longer cared. So if you want something to appear in the open source project, do it yourself. This is the rule that always works, and you have to pay for it. Otherwise, no one is going to do anything. Another important milestone, Android embraced Clang instead of GCC in 2016, and the main reason for that, well, is the quote shown in a slide. The developers who presented a talk stated that it's time to have just one compiler for Android, one that can help find and mitigate security problems. And as far as I know, Google follows the following rule. If you detect a security problem that could have been discovered by a compiler at the compiling stage, then a compiler should have an additional check to detect such problems. And it's faster and easier to do that in Clang. So these two companies, I mean Apple and Google, predefined the success of Google. They formed the origins of the success story, and then it was like a landslide joined by other companies. So, like I said, everything started with Google and Apple, and starting from 2014, ARM gave up proprietary compilers and embraced LLVM. Other vendors, that's Samsung and Qualcomm, also support LLVM. They also support GCC, but nevertheless, for ARM, LLVM is the main compiler. So if you code for ARM, then you will have to use LLVM. Well, major Silicon Valley vendors such as Intel, NXO, and Huawei. I worked for all of them. If you play video games, then 2 out of 3 main game consoles have toolchains based on LLVM. That's Nintendo Switch and PlayStation. In 2020, IBM was highlighted. IBM stopped developing proprietary Excel compilers and embraced LLVM. And this is important for the following reason. If you take a look at the compiler development history, programming development history starting from 1950s, you'll see that IBM was the major innovator. All the main discoveries are linked to IBM, followed by Intel. The number of patents is also the highest in Intel. And the fact that IBM gave up something that it considered to be valuable and embraced LLVM was a very important milestone. And all the other logos, such as national research labs that use certain mainframes, also use high-performance compilators. Palfridge, Meta, that used to be Facebook, Amazon. They all produce their own hardware, and they use LLVM compilers in their hardware. Smaller manufacturers such as AMD, Metro Graphics, Xilinx, Texas Instruments, MediaTek, all of them use LLVM compilers. And even telecom vendors such as Cisco, Ericsson, that develop tools for their telecom platforms also use LLVM. In other words, if you're using anything that generates code, I don't see Microsoft here. Well, actually, by the way, for Windows, it's not LLVM. However, Microsoft uses LLVM. For instance, Office for OS X is generated by LLVM. Despite the fact that for Windows they still use Visual C++ compilator, they still run Clang, and they do statistical analysis of the code database of at least Microsoft Office with the help of Clang, which just goes to show you that Clang has powerful positions in this domain. Right, so that was some background history, a very brief background history, but nevertheless, like I said, everyone embraced LLVM. LLVM is the #1. So what's the secret behind this success story? I believe that the main success factor is what we call in English permissive license. I have no idea how to properly translate it into Russian. So Google Translate gives you just a literal translation, so I decided to leave the English term in my presentation. GCC and many other projects use GPL license, which is oftentimes called a viral license because of strict limitations and the requirements instilled by Richard Stallman, who was the main ideologist of the free software movement. And it's viral because if you use a part of the code licensed by GPL, you have to license the entire project under GPL. You will have to provide it free of charge, it should be open, and so on and so forth. Many people don't like it, not just because they are greedy and they want to sell it, though it's part of the reason. However, large companies that develop infrastructure software, for them it's an obstacle for many reasons. For instance, GC for Windows does not support PDB for debugging because of the license limitations. You cannot use Microsoft library in the GCC that would allow you to read PDB and parse it. Therefore, commercial companies don't like GPL as a viral license. They are unwilling to use it, so that's the main success factor. This is a cartoon. Do you know who the characters depicted in this cartoon are?
Хорошо.
You don't. All right. The bearded one is the Richard Stallman, Free Software Foundation ideologist, and
А человек справа
GPL license. And the man on the right is Eric Reynolds. He is the ideologist of the open source movement and multiple open source licenses. Richard Stallman says,
там письма.
I have a SEC with the letters of support from our foundation fans. And Richard answers, I also have letters of support from my fans. Let me show you a wallet with $100 bills. That's from Microsystems, VM Linux. So that's the difference in the ideologies between the Free Software Foundation (GPL) and the open source
Помимо GPL.
movement.
Free Software считает, что
Free Software Foundation believes that corporations are evil and we need to get rid of their control, while the open source movement, represented by Eric, corporations are good if they use open source, and open source can be permitted without imposing any limitations on them so that they are forced to open their code as well. By the way, there is the Parkinson law, the Moore law. These are rule of thumb laws that are not based on mathematical equations, but just because someone invented them. Let's say I have invented the Bokhanko law, and it's as follows.
основной категории программного обеспечения
In any major software, the number of major open source projects is always equal to the number of major license. Right now there are 2 of them, so it's 2. Double check it whether it's really valid. So that's the main reason from my viewpoint. The second reason is as follows. I don't know how to translate it in Russian, but I call it benevolent dictator. And what was the name of the guy from Linux?
вот, у Python есть, и у проекта
Linus Torvaldsson, and in LLVM we also have a benevolent dictator. Linus Torvaldsson is known for cursing, swearing, flipping a bird, and he is a guy who
может ответить.
who can give you a rough answer, while Chris Latner, is a sweet guy with a sweet dog. Naturally, I picked the photos, but I worked with Chris Latner, and let me give you the following example. When I worked for Intel, my team specialized in supporting OpenMP in LLVM, and Chris Latner worked for Apple back then. And Apple did not care about this OpenMP. They had their own staff that was Grand Central Dispatch. I have no idea what they are using now. Maybe the very same product, but OpenLP was something that they were not interested in. Nevertheless, Chris spent his time to support me and my team so that OpenMP appeared in LLVM. And he said, for me, LLVM is way more important than the company I'm currently working for. I can change my employer, while LLVM is something which no one will recreate. So I value LLVM more than my role and position in the company. And I guess this is the best characteristic for Chris. He is a person who is friendly, but not too friendly. He is calm. He is ready to listen to whatever you have to say and support your ideas. It's really pleasant to work for him and with him. And LLVM community is a very welcoming one, unlike other communities, which I'm not going to name now. And the third reason, and this is the main difference between GCC and LLVM. That's the modular structure.
LLVM is a collection of reused and recycled libraries that you can combine in different ways, and the libraries are glued together by LLVM IR. That's the intermediate representation. So you've got libraries. The front end is C++, the front end for Swift, front end for Rust, And they all generate the same, LLVM IR. That's why there's an optimizer that optimizes LLVM IR, and there is a code generator. It makes the binary code assembler for the specific platform. So if this is how you combine these libraries, then you're going to have a Rust compiler for x86. If this is your combination, then you will have a Rust compiler for ARM. If this is your combination, then it's going to be a C++ compiler for ARM. And you can do without an optimizer if you don't feel like using one. And then you'll get this feature. Or you can do this, and then you'll get a static analyzer. So this is our own development from the Institute of Programming, and it's, as far as I know, they are supporting several languages. But you should better consult with them.
Вот такие три причины.
So these are the three reasons. I have already mentioned LLVM IR, and now let's start the most hardcore part of this presentation. It will take no longer than 5 minutes, so get yourselves together, brace yourselves. It's an intermediate representation. If you've never had experience with a compiler, what is it? Here is C. I hope you understand. Hello world. We've got a function. We've got we call printf library function, and we send this string. Together with Clang, this is how you get an LLVM IR in the text format. You can play with it at home. This is your string, and this is what you get. And that's not all of it. In fact, not everything fit on the screen.
Как бы мне указать?
How can I don't know, can you see if I point with my finger?
Main.
You can see main there, see? Main. That's the function that we had in the original code. Then you can see call. Call that calls the library function. You can see printf.
Дальше идет что-то непонятное.
Then something strange. It's because printf in C is a variable number of arguments function. So there you see some indicators. 14 elements, I8 type. Probably it's our line. It's our hello world. It's our text, right? No? Hello, comma, world. Then there is something else. Something else is relayed.
Функция у нас маленькая.
Then this is a small function. Then red.
Типа I32 и возвращается нолик.
I32 type. And
Дальше у нас объявление функции printf.
0 is returned. Then printf, because this is a library, doesn't have a code.
Тоже что-то непонятное.
Then something strange again.
Отлаженная информация.
In fact, this is debugging and other meta information. For instance, who generated this code? Clang version 6.0, launched under Ubuntu.
Вот так вот выглядит. Очень похоже на ассемблер, правда?
This looks like an assembler, right? And Chris Ladner says LVM IR is an assembler with vectors.
Так, теперь давайте то же самое сделаем для...
Let's do the same for Rust.
Язык совсем другой.
A different language. Is it going to look similar? Yeah?
Сейчас увидим. Так, вот как выглядит программа на Rust.
So this is Rust.
Вот как получить с помощью компилятора.
This is how you get Rust C output. You can play with it, and this is the output.
Это потому, что...
It looks different. It's because in Rust, what is it? Print? What was it called? Println. Println is a macros that decomposes into lots of different things. So it's probably not the best of examples, but over here you see a function. It has a name, really weird-looking name. Hello, main something. But this is how mangling works. But if you unmangle this, you will have hello and world. Then load.
Биткаст.
Probably coming from memory, then bitcast type conversion, and then call. Here is call.
Вызываем, хрен поймем.
Do we call? I have no idea what we are calling.
И вот, наконец, вызываем print.
And finally, we are calling print. And we return a void.
Я не программировал на Rust.
I never programmed on Rust, but probably this main function returns a void. So yeah, the appearance is different, but for different
Похоже на ассемблер.
programming languages, the same IA was used, which looks like an assembler, and it may look an independent, but it is in fact dependent because different platforms have different features, and different scales, different
Более-менее независимо от платформы.
parameters. But this LLVM IA is more or less independent of the platform.
Значит, LLVM-IR — это клей.
The hard part is over. LLVM IA is the glue for the whole LLVM project. You can write your own language and your own compiler.
Все, что вам нужно сделать, это
I know I'm simplifying things, but all you have to do is write the front end that will be performed by LLVM IA, and everything else will be done for you. This is what Rust did. And immediately they obtained a compiler that also optimizes Rust and also targets many different platforms.
он обратно совместим текущей версии.
There is reverse compatibility. The current LLVM version can read binaries from LLVM 3.0, and the current version is, if I'm not mistaken, 18.0. So that means that you can read very old files. It's language agnostic. It's platform agnostic. It supports a huge range of platforms, all the very popular ones and the least popular as well, like Power architecture and stuff.
Можно сказать,
And you can say that probably this is the lingua franca. You know the lingua franca, what it means? It means a universal language
с помощью которого можно выразить все на свете.
that you can use to describe anything.
Потому что
But actually it's a problem because LLVM-IA is a very low-level thing. It's an assembler with vectors.
LLVM-IR не представлены как отдельный тип данных. Поэтому
Certain types of data are missing from LLVM-IA. So for Fortran, for instance, you still need optimizing. Fortran was made for math, and Fortran is not possible for LLVM-IA. Or in C++, you can do devirtualization because of the language properties, but you can't do devirtualization in LLVM-IA. That's why several years ago, MLIR came on stage. So I will just run quickly through this topic right now, but later today there will be a full-fledged presentation on the MLIR. If you're interested in more details, please come here later. Chris Liner suggested various interpretations for this acronym: machine learning IA, multi-language IA, module language IA, Moore's law IA. But multi-level IA, in fact, is the official interpretation of this acronym. It's a method of an IA
свои типы данных,
to which you can add your types of data
операция.
and your operations,
Причина главная появления вот этого.
transactions. The main reason is for emergence of this tool is machine learning. Multidimensional matrices needed representing, and artificial intelligence is multiplying matrices, right? Basically, that's it. They are operations with matrices. So these procedures had to be optimized somehow. And TensorFlow, Chris actually moved to Google to get financing for this research. So he developed MLIR, and one of the first dialects, probably the first one, was for the TensorFlow, for which which exists basically for a multidimensional matrix. Just like with the other things, products that Chris produces, they immediately conquered the world. Same happened with MLIR, TensorFlow, PyTorch. The third one is, what is it, Triton, right?
OpenAI.
This is OpenAI. It's what they are pushing now for machine learning. Then Mojo and XLA,
Это важная часть TensorFlow. Вот
which is an important part of TensorFlow.
MLIR
So all of these use MLIR and LLVM to generate code. My time is running out, and so does my presentation.
Расскажу немножко.
So I'll tell you a little bit about the LLVM umbrella. Compilers, machine learning, we said all the proper words, but you know that LLVM is not about compilers, not about virtual machines. It's about everything in the world that's related to the title of this track. Languages and tools. Any languages, any tools. Well, first of all, compilers.
Эмблемы языков.
Here you see logos of different languages. Carbon at the bottom,
C такая в черном.
C, the C in a black circle. Everything else, well, up to you. You can guess what languages these logos represent.
Все на основе LLVM сделаны.
All the compilers for these languages are based on LLVM, the most popular ones. And then there are other languages for which the main compilers are not based on LLVM, but they still have an LLVM version compiler, and that version is also highly used. LLVM is libraries, C++, C standards, OpenMP library, libfuzzer. And there is a presentation later today about fuzzing. I don't know if you're going to talk about libfuzzer, but LLVM is there as well. LLVM means tools. Xcode, C-line creates a sanitizer, debugger, everything. Machine learning. We have just covered that. Why? Why is that so? In the JSC project, you wouldn't find the decimal part of it. Why? Because of permissive licenses, benevolent dictators, the modular structure that allows you to do everything quickly, and I will add one more reason. Completeness. I don't know how to say that in Russian.
Все эти вещи, они дополняют друг друга. Ну, такой пример. Если
all these things complement each other. You see, in C++, if you add a new feature to the library, probably you will need to support certain languages of certain features of the language that are required for this feature in the compiler. So it's best if you develop everything together.
Так, ну и обещано, а что же это значит
Now, I need to keep my promises. What does it mean for you, and what does it mean for us?
Я думаю, что, надеюсь,
What's in it for us? Well, I think I convinced you that LLVM affects all of us. If you are anywhere in IT, then you will come across LLVM sooner or later. So it makes sense to learn about it a little bit more. You have already made the first step. You are attending this session. If you want to make another step, then you are welcome to join the LLVM.org community. There you'll find lots of publications on LLVM now. Second, let's contribute to LLVM. If you are contributing, then your impact will be indescribable. If there is a core library, if you contributed to this library, then you will be affecting the whole world. And I think that in this respect, LLVM is cooler than any other open source project. If you want to develop a new language or a new tool, you know the answer. And if you need help, I'm not sure I will be able to help absolutely everyone because my time is limited, but here is my email. Please write to me if you've got questions. I've got a lot of experience with LLVM, and I will try to point you to an answer. Thank you very much for coming. The QR code, what do we do, Andrey? Yes, you have to rate this presentation, please, with the highest rating. Yeah, let's first applaud Andrey. Thank you very much for a brilliant presentation. It's wonderful to listen to someone who is an insider. And fuzzing, yes, in the libfuzzer will be mentioned there definitely. So, no, it was not a collision. No collision, no conspiracy. No, like I promised, an end-to-end narrative. Everything is linked with everything else. And thank you for showing us the Kotlin logo as well, because Kotlin also has Kotlin natives that use LLVM, not widely used. And Yeah, it's right. Questions. Can I have a question? Because I really want to know if all people that were working with Clan, LLVM, if they all now, if they all found jobs, if Chris Latner is on Mojo, if Chandler is developing his own language, who's left in the office? You know,
Диктатор есть.
is anyone home? Well, the dictator is home, and it's Chris Latner, and he believes that
С миллионом долларов заработать.
it has always been his idea to remain the leader of the LLVM project, regardless of all his other assignments in a project. I'm not sure if he's still coding. About 3 years ago, sometime before the pandemic, he said that in terms of commit, he is still number one. Yeah, probably he follows the Linus Torvaldsson role model. Besides, in this community, there are lots of people who speak Russian. It's one of the most Russian-speaking communities in open source. Mostly these people live outside of Russia, but again, it's a Russian-speaking project. But you're not going to get a T-shirt. No, what a pity. Yeah, we received lots of questions. In fact, well, let's start. Well, okay. Sergei Balshov is asking, portable executable format. Is it something parallel to LLVM or independent? Well, it has definitely nothing to do with LLVM portable. I'm not sure if you're asking about some specific format. If you're asking about a generic name, no, it has nothing to do with LLVM, because LLVM, once again, it supports many targets. But when you start the same Clang, for instance, you have to identify the target, and the LLVM IR, the resulting one, will not be valid for another target because of the fine differences. So it's not of this format. It's not the same as portable executable. Questions, beautiful questions. Someone called Sigun is writing, the size of the binary does go up after compiling with LLVM IR, and if yes, then how bigger will the binary be? But there is also a compression option. You can compress binaries. Oh, I'm sorry. Let me take this question. As to the size of the binary, probably compared to GCC or compared with other compiler. Well, compared to what? More than what? Well, the answer is all compilers are trying to optimize. And when we say optimize, usually people mean faster performance. If the size of the code matters for you, I worked for NXP, and for them the size mattered. They manufactured chips, and for them the size of the code was the greatest priority. So there is special optimization that can target that, and you can find that under OZ and Clang. I don't know about Rust. Maybe they do not have this feature in Rust and other languages, but they have it in Clang. Okay. Another question. What's the root difference between GCC and LLVM compilers? Well, that was the whole. That's what the whole presentation was about.
Технологии, там, не знаю, алгоритмов и так далее.
Technologies, algorithms, I'd say it's pretty much the same.
Две вещи, которые не технологические.
But two things that are not technology related. Well, semi-technology related. GCC is a melting pot of 30 years ago, and it's very difficult to modify it. And companies who support it, they say that it's very difficult to answer. But in an LLVM, if you want to produce a new language, there is a tutorial on the website how to produce a compiler for the new language. If this is your task, then please select LLVM, not GCC. I talked about the license. It's not a technical difference, but still, And from my subjective point of view, all new ideas in the field of compilers initially emerge in the LLVM community rather than GCC. They they tend to migrate from LLVM to GCC. It's not like a noodle structure, it's a modular structure, plus the license, plus the support of commercial companies. So all the, the most fashionable stuff happens in LLVM.
Значит, подскажите, пожалуйста, сравнивание
Last question.
производительности одного и того же приложения с
Performance of the same app compiled with LLVM and GCC, was the difference?
математические алгоритмы все еще не писать напрямую на ассемблере. Какой-то бешеный человек пишет, да?
Да нет, но про
Нет,
спек
почему?
сейчас
Нормальный
будет ответ
вопрос.
про спек.
Well, I think it's an okay question. There are actually several questions in there. Was there any benchmarks? Yes, there were.
Может
And not necessarily one compiler is faster,
столько аспектов. Платформ,
because many different things come into play. The type of the program, the type of the platform, the set of options. Sometimes GCC does the job faster, sometimes it's LLVM. So I'd say that they're comparable.
выигрыш, использование,
Is there any advantage to in using a compiler?
конечно же, дает.
Yes, there is an advantage in using a compiler.
Такая программа в телефоне.
Again, depends on this application. You know, the torch in this light in your phone. This
Автоматическая программа, то там выигрыш производителя.
app can be compiled with anything. You will not find any differences. But if it's a mathematical software, like Intel and ARM, they manufacture a new processor for math. Are you going to rewrite everything to two different versions of the same software? It's too difficult, too cumbersome. I'd ask a compiler to help me. And there are already cases when compilers